Now let me put everything in words. So we have seen two types of complements. One is b minus 1's complement and other is b's complement. So let me talk first about the diminished radix complement. Diminished radix complement. So before starting, keep this one in mind. We are talking about unsigned numbers only, which means we are talking about two numbers. These two are positive integers, right? And they are not zeros also. These two are positive integers. M can be 0, but n is not equal to 0. Now the main problem is when we want to add these two numbers, we can do with an adder, but when we want to subtract it, we are supposed to design a subtractor, but we don't want to do that. We want to perform the operation using the adder, and so we are going for complement form. Now see these steps. The subtraction of two n digit unsigned numbers m minus n in base b. So we are talking about base b, and we are talking about diminished radix, which is nothing but b minus 1's complement. Keep that in mind. Can be done as follows. The first rule is, what we do when we have to subtract m minus n, what we did, we have left this m as it is, but then to the n we just modified it to r minus 1's b minus 1's complement, which means we are going to compute the b minus 1's complement of n and add it to m. See this, add m to b minus 1's complement of n. That is what we are doing. Now what happens if you do that? This performs. So finally what happens is, we are taking m and then adding b minus 1's complement of n, which means b power n minus 1 minus n. How can we write it? B power n minus 1 plus m minus n. This is how we can write it, isn't it? So this is what has happened. This performs this one. So this is the result we get. So now what happens is, if this factor m minus n, if m minus n, if this one is greater than or equal to 1, if this one is greater than or equal to 1, then the minimum value here will be 1. Then 1 and 1 will cancel out, and so it will produce b power n. B power n is nothing but the carry out of the most significant digit. See, we are adding two n-bit numbers, right? And the result is going to get a value of b power n. When the result this one, when the sum is greater than or equal to 1, then definitely there will be a carry out here, isn't it? So b power n we will get only in the case whenever this one is greater than or equal to 1. Therefore if m minus n is greater than or equal to 1, then we will get a carry. That is what I am saying. If m minus n is greater than or equal to 1, then the sum will produce an end carry. End carry means this one. Then the sum will produce an end carry b power n, which will be discarded, and 1 is added to LSB. Okay, which means we are saying that this one will be discarded and 1 will be added here. Why will it make sense? Because when we discard this one, then b power n will be ignored, and then 1 will be added back. When 1 is added back, this 1 will get cancelled. Therefore we produce m minus n, which gives m minus n. So in this one, the case is simple. Okay, so how can we know that m minus n is greater than or equal to 1 or less than or equal to 1? Simple. Check whether the carry is produced or not. So one other way of understanding this one is, without understanding this all, whenever you are trying to do this b minus 1's complement, whenever you try to add one number to the b minus 1's complement of the other number, then see if the carry is produced. If the carry is produced, take that carry and add it back. That is called end around carry, right? Take that carry and add it to the least significant bit of the sum. Then whatever you get is the answer. And the other case is m minus 1 is less than 1. If m minus n is less than 1, then less than 1, then what happens is, the maximum value possible will be b power n minus 1 in case if it is 0. Otherwise the number will be less than b power n minus 1. So whenever the number is less than b power n minus 1, see, with n bits, the maximum number representable is b power n minus 1. So if the result is less than b power n minus 1, definitely there will be no carry. Therefore, this third point applies whenever the result does not produce any carry. See this, if m minus 1 is less than 1, then the sum does not produce an end carry. To obtain the familiar answer, to obtain the answer in familiar form. Why familiar form? Because whatever answer you get, you will not be able to understand it. Later you will understand it, but for now you will not understand it. Later I will talk about it. Okay, so you will not understand it. Therefore, in order to convert it to familiar form, what you are supposed to do is take the b minus 1's complement of the sum and place a negative sign in the front. Why will this one work? See this. Now whatever we are going to get as the result is not m minus n, the result is b power n minus 1 plus m minus n. This is what you are getting. Now what is this third step saying? Whatever you got, the third step is saying find out the n minus 1's b minus 1's complement. So if you find out the b minus 1's complement, what happens is it is b power n minus 1 minus this entire thing. Then if you expand it out, the result will be minus m minus n, right? So once you find out the b minus 1's complement, the result will be this. Then what are they asking us to do? Put a minus sign before it. If you put a minus sign, minus into minus is going to be plus, which is nothing but m minus n. That is what we wanted, right? So again, keep it in mind, we are dealing with unsigned numbers. We didn't go into the signed numbers. Once we go into the signed numbers, then I'll tell you, they will, even if you understand the form, whatever answer you get even in this point number 3, that you can directly understand that it is a negative number. But then we have to go into the signed numbers and look into that. For now we are talking about unsigned numbers. Okay. Now let's see what happens in B's complement. See this. So in case of B's complement, which is nothing but radix complement, not diminished radix complement, it is the radix complement itself. The subtraction of n digit unsigned number m minus n in base B can be done as follows. Add m to the B's complement of n, not b minus 1's complement, B's complement of n. Then what does it perform? It performs the action m plus b power n minus n. Then what does it mean? That is equal to b power n plus m minus n. Got it? So now there are two cases. When will this result produce a carry? Whenever m minus n is greater than or equal to 0. Even if m minus n is equal to 0, the result is going to be b power n, and b power n is nothing but producing a carry from the result, isn't it? So if m minus n is greater than or equal to 0, if this is the case, then the sum will produce an end carry b power n, which will be discarded, and there is no need of 1 added, which will be discarded, which gives m minus n. So why is it true? Because once we discard that b power n, see this, now we are saying that after performing the B's complement of n and adding it to x, we are supposed to perform x minus y. For that we are taking the B's complement of y and adding it to x. Therefore the result is going to be b power n plus x minus y. So we have this extra factor b power n. So in case if you find out that the result is producing a carry, then simply discard the carry, which is nothing but discarding this. Then we get the answer m minus n. That is what the second point is. What about the third point? If m minus n is less than 0, if m minus 1 is less than 0, which means the minimum number is minus 1. So if this one is minimum minus 1, then what is the maximum value possible here? B power n minus 1. So this number need not produce any carry, because this number can be represented within n bits. Therefore here, in order to delete this b power n, it is not possible directly. Then in that case, what we should do? See this. Then the sum does not produce any carry. To obtain the answer in familiar form, as of now you are not good with this form. It is not familiar to you because we didn't discuss about 1's complement signed number system and 2's complement signed number system. Sorry, B's complement and b minus 1's complement signed number system. Got it? We are not familiar with that. Therefore as of now if you want to get it in familiar form, you have to find out the B's complement of the result. So what do you get by taking the B's complement of the result? If this is B power n plus m minus n, then how can we get the B's complement of the result? You have to subtract B power n, right? Then what do we get as a result? Minus m minus n, right? So this, we wanted only B minus n, therefore we have to put a minus sign before it, then we get m minus n. This is what we wanted. Now check this. If m minus n is less than 0, then sum does not produce an end carry. To obtain the answer in familiar form, take the B's complement of the sum, which means take the B's complement of the sum, which is going to give us the negative of m minus n, minus of m minus n, and place a negative sign in front. That is how we do it. Again, keep in mind, we are again dealing with only unsigned numbers. I didn't get into signed numbers, therefore you will not understand this form. The whatever answer you get in the third case, you will not understand it. That is why we are converting the answer. Later, once we deal with the complement number system in detail, you will not do all this. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.